I know, that's creepy, sorry. Again, whenever you're ready, start kind of discussing your answer, compare, contrast, maybe see some insights.
Oh, okay. Okay, I'm confused on how to spell it, but like all the
as a different method. Yeah,
because I did 45 minus 30. Would we do that half?
Because that would beta would be sine.
Or 30 over 2.
Yes. Beta over. Oh yeah.
Wait, shoot, wait. Is it 1 minus cosine?
Yeah, cosine is 1 plus 2.
Cosine is the half angle for cosine is plus. Half angle for sine is minus. Great, thank you. Cosine.
How did you have?
So sine of 180 is 0. Oh, because it's
Where did you guys do that? Cosine.
Yeah.
Okay, great. Okay. No, I was like trying to remember if 300 was the angle on the circle.
Oh, yeah, over 4. Yeah, so you multiply the.
Is equal to
Same thing for the, for 2.
300.
What do you get for 3?
No, minus.
6 plus.
Plus.
Yeah. Plus.
Cosine.
And then how do you do it differently? Wait, so for me, I said, I compared it to number 2, right? And so on a right triangle, it's 90, 75, 15. So the opposite of 75 is going to be the adjacent of 15. So those are the same. It's the same answer. What do you do?
Oh, you did? Oh, wait, that's why.
Wait for. Your sine, the sine is off.
No, cosine, sine is opposite.
Already? Jump through 2.
So then why isn't this positive? Because it should be plus and sine 1 is negative this, so it should be plus this, so this should be minus. Sine is.
If it's 15 degrees, that means that it's only going to be positive. Because it's in quadrant 1. We're so good at this. Okay.
10 seconds.
Oh. Whoa. It's 1 minus cosine theta over the square root of 1 minus cosine theta over 2.
Yes, and it's plus or minus.
Okay, folks. Let's get the show on the road and finish up your discussion.
Yeah, I didn't see.
There'll be time for more, but for right now, I just would like to hear from. Let's see. Nico, what'd you get for number 1? All over 4? Do we agree? Thank you. Nico, would you also like to tell us what you got for number 2?
Also not.
Okay. Did you get to number 3? And what'd you get there? Interesting. They're all the same. Is this true?
We got.
Different.
Negative root 6 plus root 2.
Ah,
Yeah.
okay. I'd like to offer some insight about these first 3 questions. Anyone? Yes, Noah.
So we have that kind of issue because we had them research mentioned to before, but they had it just said. So I think the only thing I noticed that was different was we started with 45 degrees plus 120 instead of the sign. They started.
Oh. Okay. Well, as long as it ultimately, like for that second one, as long as it ultimately adds up to 75 degrees, it should be the same. It shouldn't matter what the direction we take to get there. It should be the same. Yes, Shane?
1 and for like 3, you don't really have to solve it out. You can just say that 165 and 15 are the same.
Really? We could just say that?
No, but for
Is
the
this
sign,
true?
the sign values of it is the same.
Is this true? Wait, how do you know this?
Because it's like equally far apart from that.
Right? We're just looking at the Y value, right?
Think that I totally.
Okay, so number 3 for sure is the same as number 1. Do you agree? So if you got something different, then one of them is, at least one of them is wrong. But how about that second one? Shane, thank you. That was deep. I like that. Thank you. How about that second one? Why are we getting the same thing? No? Shane, 200?
2.
Oh yeah, for number 2.
Yeah, so what I did is like I drew out the right triangle where it's 75, 15, and 90.
Okay, so like this, 75, 15, and 90.
And then like let's call it sides A, B, and C.
Okay.
And so the sine sine of A, right, is B over C because that's opposite over hypotenuse. And that's the same as the adjacent over hypotenuse or the cosine for both two.
Oh, so like this? This kind of thing. They're both, if it is the way I said, then these are both equal to A over B. What do you think? What's the idea that Shane is hinting at? What's that? The co-function identity. Remember, co-function identities deal with what kind of angles? Complementary. Take a look at the angles in numbers 1 and 2. They're complementary, which is why, Shane, we were able to put it together in that triangle. Big brain. You can still say that? Do they? Okay, good.
Not when I was in honors pre-cal.
No. Oh, no. Okay. That's funny. That's a tough class. I don't usually divulge this kind of stuff, but David's first test, 100%. God.
Day after he
I took it the day after he told me.
Rough.
That's the stuff of legends.
Wait, with the curve, like the 18 points, he got all 118.
I don't know the specifics. It's actually slightly more than 100%. It's slightly more than 100%. Yeah.
That first month you cleared.
I got
66. I got 69.
Shane, can I
Oh, sorry. about
Levi,
that.
Shane's got you. So he's gone to the right place. He's definitely. Okay, yeah, but the fact that 15 and 75 are complementary, we could have done it before, like without any sort of calculations. So also numbers 1 and 2, I imagine your calculations were exactly the same when you wrote it out, weren't they? Exactly the same. Like you took the 30 and 45 and just like switched places and something. So of course it's gonna be the same. But had you looked maybe a little bit into the future, maybe we could have seen that, based on what we already know, which is nice and getting the big picture. Is 4 going to be the same thing? So I'd like to get some insight for number 4. Zach, what did you get for number 4?
Yeah, root 2 plus root 6 over 4.
Root 2 plus root 6 over 4? Is this true? Is this what you all got? Okay, and what angles was it that you used?
It 340.
300 plus 45 degrees, right? Okay, nice. Did anyone use different angles? This is great. This is probably what I would have used too. Any other suggestions for angles to use there? 315 and 30, that would make sense. I really liked, one of the students in my other class said 30 minus 45. Does that make sense?
Yeah.
That's really nice, isn't it? That's more big brain. Yes, Maria.
I didn't know it, but I don't know if this is like a smart way, but I didn't like cosine of 360 minus 15.
Cosine of 360. Oh, look at that. There's 360 minus 15. Okay, that works.
Like the sine of 60 would end up being 0, so like that term would cancel out. So you're like
Ah,
1 times root 6 plus root 2 over 4, because you already know cosine of.
wait a minute, wait. So 360. I'm really interested in this. This is cool. So I know from my identities that this is going to be 2 cosines. So like this, and then it's going to be plus and 360. Oh, this is interesting.
And then I did the cosine of 360 is 1.
Cosine of 360. Okay. Do you agree with that? This is 1. So this is just cosine of 15. And then sine of 360 is
That's
0. So we get that cosine of 345 degrees is equal to cosine of 15. I feel a little empty.
I said it was 1 times, like, the first term I got like, because cosine of 360 times cosine of 15 degrees, I did like 1 times root 6 plus root 2 over 4.
1 times.
Cosine of 15. I did it for a
She-
reason.
You just had cosine 15 in the computer problem.
Yeah,
Oh, so you did cosine of 15. Right now it's. Okay. Yeah, so it's fine for you to bring in prior knowledge. So thank you for pointing that out, that we could say this. But I hope that this also makes sense. Does it make sense that the cosine of 345 is the same thing as cosine of 15? Why does that make sense? Same x coordinate. So thank you for the insight. Very nice. And number 5, what the heck was I talking about for number 5? What was I looking for you to do? Half angle. Okay, so let's do it. Sine of, I'm going to express that 15 as a 30 over 2. Is that what you did? At least in my mind, I'm thinking of it as 30 because that's what I'm about to relate it to. So should I do plus or minus? How do you know it's plus? It's 15 degrees. It's in the first quadrant. It's for sure positive. So please don't put a plus or minus. And if you know where it is, and inside it's going to be 1/2 times 1 minus cosine of 30 degrees. Do you have this somewhere? Nice. And that works out to be 1/2, 1 minus cosine of 30 degrees is what? Root 3 over 2. And we could stop. That answer is fine. Yeah, that answer is fine. And if you want to go a little bit more, you could
all out.
2 root 3 over 2 over 4, right? I think that's what it works out to be if you combine them. What's that? Oh, and then take the square root of 4. That would be, actually, I think this would be most appropriate. And this is equal to, do you know what this is equal to? Root 6 minus root 2 over 4. Right, the same thing that we have for number 1, number 2, and number 3. But I don't need you to simplify it further. Do you have any techniques to simplify this? Someone said square it in my last class. Is that okay to just square a number? If you have an equation, it's okay to square both sides, but you can't just go around squaring stuff like square 1/2. You get 1/4, and that's different from 1/2. So you can't just square it, although that would be pretty. Yeah, so I don't want you to worry. If it's a test or quiz, just leave it in that form. Just leave it. Don't think I need to simplify somehow. If
Yeah.
it makes you rationalize stuff.
Yeah.
You're so lucky to have that experience. You know what else you're lucky to have the experience of? Not yet. There's an exercise before the quiz. Perhaps you've seen this exercise before. It looks like this. I offered my other class.
Can this be the quiz instead?
Yeah.
Offered my other class $1,000 for anyone who could do it in under 2 minutes.
$1,000?
I'm getting
The thing is, you have some new points. You have 15 degrees.
Huh?
So not just normal points. I also want 15 degrees. I also want 75. I want.
Joking. Wait, you're joking, right?
I'm totally serious. So I want the in between.
What?
That's why we just did it.
Can we have like?
What?
Yeah, coordinates, degrees, and radians. Let's make it 5,000 big bucks.
10,000.
Wait.
10,000.
Are you collecting these ones or no? Oh my god. We're collecting it then.
I hope I can do the degrees.
Yeah, there is no institution.
That's it.
What, then we just do 15 degrees? Sine angle?
No, there's not one. No, that one just got 36. Like he just wants you to fill it in.
I feel like,
I fear.
just a minute.
Can we just like?
Let's see. Now, we already did the 2 coordinates for this one, didn't we?
Can we draw the line?
You could draw it, or you could just put a point there if you want, but I do expect you to do radians, degrees, and coordinates in the other 1, 2, 3, 4, 5, 6, 7, 8 places. So this should, yeah, all 8 blank places. Yeah, that's for you to discuss with your neighbor. Yeah, for you to discuss with your neighbor. You could do it. I believe in you.
We're not filling in the regular.
Oh, regular too. You're wasting the 2 minutes.
Wait, so then.
Degrees, radians.
Start off with what
We just size.
Yeah, that's true. Neighbors, let's start by filling out the normal.
Yeah.
Okay.
And then we can reconvene up.
Considering the warm up, you should all be able to do that first 15-degree area. Yeah, you can have it open. It's an exercise. It's an exercise. So you're doing the safe ones first?
I don't know.
Oh.
I saw a part.
And once you finish that first quadrant, check in with the neighbor, the extra ones. And if you're having trouble with the extra ones for the first quadrant, discuss with your neighbor. We did those. Oh, leave those ones. That's right, she just moved you two next to each other.
Yeah.
Did we send it next to each other during the one?
Yeah, I think so.
Did you? Look at the
Yeah.
homecoming.
Here we, sorry. Okay.
$75 degrees.
Like after.
Yeah. Okay.
Well. Yeah, okay.
Radiant. He said it'd be radiant. Radiant. No, I said radiant. You can laugh about it.
Wait, what is it? Cosine of.
Oh. Over 4. Yeah. Or like.
Five.
For the.
How is it one?
We already found it. Yeah.
That's not,
Seven.
because that's the same as saying that.
Okay, I can.
I just want to make sure we're all in the same boat. I know that this right here is 15 degrees, isn't it? Do you get the radians? Is it pi over 12? We never talked about pi over 12. How did you know this? It's half of pi over 6. So pi,
I said 5
pi over 8? Oh, that's okay. We forgive you based on what we did earlier. But the coordinates, how are you supposed to know the coordinates? We just did it. The last problem, number 5, is the x coordinate, isn't it? How do we know that? Because if x coordinate is the cosine of that angle, we just figure that out. How did you write this? What's on top? Root 6 minus root 2, is that what it is? Oh no, plus root 2, isn't it? Over 4, the x coordinate. And then the bottom is, I saw the y coordinate is root 6 minus root 2. I just feel like you could use this information in all the blank places, can't you?
Right. Right. Oh.
I over
6 plus. Okay. 105. Is it just 105? What? It's like 7. Okay, Queen, you too. Who knows?
Okay, wait. How do you convert degree to radian? You do time?
Shouldn't have to do any conversions. No conversions.
Oh.
Just count. 1 pi over 12, 2 pi over 12, 3 pi over 12.
Oh, I see it.
5 pi over 12 is after 4 pi over 12.
Wait, I'm just lost on the pi over 12.
Oh, yeah, you were right. 7 pi over 12.
Oh, and then you just use the 11 coordinates. Negative 6 plus root 2 over 4. Oh, this actually isn't too bad.
Oh, I hope not. I didn't mean to torture you today.
Want to see?
Wait, it would be 7 pi over 12, 11 pi over 12.
Oh, sorry.
Oh,
You just.
my bad, queen.
And you keep going, because the last one's 24 and it's too high.
Preach.
I see the little paving and I suppose them have down.
So,
Oh.
Not very good at reading math upside down. Yeah. Let's check this in another.
No, it was what I was doing. I mean, I'm just.
That's how I know.
The negatives.
It's not a bad idea. Well, just be clear about what your answer is.
Like if I put parentheses around it, that's fine.
Could always be wrong, you never know.
Good five. I get it. But you finish in 2 minutes.
I think.
It's both. It was like 2 of maybe, maybe. two.
Mom,
That's
okay.
another 10 minutes.
That's gonna kill it.
here,
Okay, thank you. I appreciate it. Oh.
the Hana jokes on all of it's like basically you're like,
Read
you're gonna be on the quiz. I'm kidding, I'm dad.
You know, like, this would not be on the quiz. I don't know, we already done it. But hold on. I think it's so much.
I know, that's it.
You almost done?
Maybe.
Yeah.
This record was like a 98. Yeah. It's possible. It's possible. Yeah.
Who?
You see that too?
I knew there's a contest.
And which Margaret, he did it like, he was like literally done so bad, and David was it for the sophomore.
Okay.
He got beat by Dr. Humphrey.
Oh, wow.
Yeah.
That's pressure though.
Yeah. I got calcium.
Yeah, it was so good.
I said, this
Yeah.
is wrong.
Okay, let's just do a couple of these, make sure we're on the right page. I'm not gonna do this one because you just take these coordinates and flip them, right? So, but over here, who'd like to tell us what they did for this? Yeah, Lydia?
Same thing that you would get for 75 degrees, except the x would be negative.
Can you give me,
So-
tell me specifically, because this is blank, so.
Oh, well,
Oh, do you have yours?
oh, well, yeah.
Okay,
Like, what I did was like, first I solved for like the 15 degrees one, and then I solved for the 75 degrees one at the top.
I just want to know the answer.
Oh, I thought you were asking
I
the
s-
method.
Oh, no,
not
I appreciate that.
negative, root 6 minus, or like negative, and then root 6 minus root 2 over 4.
So like this? Is this what you're saying?
Oh,
Or are you saying negative
negative.
root 6 minus root 2? Like this?
Then, wait, like I
Like that?
kind of cut off.
Oh, I'm sorry.
Yeah,
Like that.
and then like for the y, it would be root 6 plus root 2 over 4.
Do we agree?
Yeah.
Okay. Can we clean this up a little bit? It's correct. It's correct.
Negative root 6.
Would that be?
Yeah.
Would that make sense to use that? Either one is fine. But just make sure that if you're putting that negative in front of the fraction, and it's difficult to say, just make sure that's obviously in front of the fraction. Because if you put it up here, then that changes everything. Okay, thank you. That was great. Oh, even tell me the radians and the degrees.
Oh, the degrees for that one would be 105.
Incredible. And
And
radians?
then the radians would be 7 pi over 12.
Are we good with that?
Yeah.
Makes perfect sense. Right, everything's based on, really, if you have these coordinates, it's just about moving them here and there. Let's do, I don't know. I'm gonna trust you to finish the rest and do it correctly. If you're not sure about that, then you could check against Lydia's. Shall we do the quiz?
Good luck, everybody.
Well, we-